In the future, humanity may leave the Earth behind and search for a new home in space. But where? Our solar system is a dangerous place. There are fiery volcanic worlds, planets with 1,400-mile-an-hour winds, clouds of deadly acid, temperatures hot enough to melt lead. Among these violent worlds, are there planets where we could one day live? We're on a voyage to find out, to explore the planets in our solar system and beyond. Our mission, to hunt for new worlds, to find a place that one day we might call home. Imagine a city with 200 billion stars, so vast that a jumbo jet would take 100 billion years to cross it. We call it the Milky Way. On the outer edges of one of 6 spiral arms is our own star, the Sun, and its orbiting planets. One planet has life, Earth, with its oxygen-rich atmosphere and oceans of water. Life can flourish here. But our world is changing. Climate change is melting the polar ice caps. Sea levels are rising. Over the next millennia, land may disappear under the oceans. Vast areas could become uninhabitable, making the planet dangerously overcrowded. We'll need more space if we're all to survive. This is a journey through the solar system and beyond, hunting for our next home. We'll discover a surprising planet that could support life in its atmosphere.
It is a comfortable temperature and pressure. I think that life could exist.
But there are also deadly worlds where we stand no chance of surviving.
You couldn't just fly through the system and survive. You would fry up.
Finding a new home is not going to be easy. We evolved on Earth. Where else will we find a planet we can even survive? Our journey begins with Mercury, the closest planet to the Sun. Data reveals it has an atmosphere with traces of oxygen, but could it sustain human life? Its surface suggests a violent past. Asteroid impacts have left it cratered and scarred. But today, those impacts are rare. They happened 4.5 billion years ago, at the birth of the solar system. Asteroids were everywhere, junk left over from the formation of the planets. Impacts were common, and some of them were huge. On Mercury, one left a crater 800 miles across. It sent shock waves rippling through the surface. A Mercury quake. The collision was so great, it buckled the crust and pushed up a range of hills on the other side of the planet. Today, the solar system is a calmer place. The problem with settling on Mercury isn't from the threat of asteroid strikes. It's temperature. Mercury rotates very slowly. A day here lasts 58 Earth days. The dark side faces away from the sun for so long the temperature plummets to a staggering 300 degrees Fahrenheit below zero. Around 3 times lower than the coldest temperature ever recorded on Earth. At the same time, the side facing the sun can hit a scorching 840 degrees, as hot as a blowtorch. A temperature so brutal that almost all Mercury's atmosphere long ago evaporated into space. What oxygen is left is extraordinarily thin. There simply isn't enough of it for us to breathe. There have to be easier places for us to survive. Maybe we just need to be further from the sun. The next planet out is Venus. Venus is a close neighbor of Earth, about 26 million miles away. It is shrouded in a thick atmosphere that completely hides the surface from view. Scientists used to think that would protect the planet from the sun. They imagined Venus's surface to be like early Earth, that tropical forests covered the land and oceans of water lapped the shores. Professor David Grinspoon is an astrobiologist at the Denver Museum of Nature and Science, specializing in the evolution of Venus.
People assumed that it was sort of a dripping wet place, and in fact the image of a sort of tropical paradise with tree ferns and maybe even dinosaurs, a kind of primitive tropical Earth-like place, was a common scientific view of Venus really right up until the beginning of the space age.
The Venusian surface intrigued scientists. What was really going on beneath the clouds? In the 1960s and 70s, while NASA explored Mars, the Soviet Union turned its sights on Venus. The goal was to land and photograph the planet's mysterious surface. Codenamed Venera, the Soviet program made countless successful launches, only to mysteriously lose contact with its probes as they entered the Venusian atmosphere. But in October 1975, the team hit gold. Venera 9 beamed back the world's first surface images of Venus. Rather than a lush green world, Venus was a barren desert. Could humans survive here? Recently, astronomers have built up a detailed picture of Venus's atmosphere. Imagine a probe hurtling toward the planet. What would it see? 50 miles above the surface, it hits a thick layer of cloud. But this is no ordinary cloud. It's made of vaporized acid, corrosive enough to burn through steel. Scientists believe that the acid clouds are a byproduct of Venus's violent history. Gigantic volcanic eruptions blasted billions of tons of sulfur high into the atmosphere. There, it mixed with water vapor to form concentrated sulfuric acid. As the probe breaks through the upper atmosphere, it slows to make a low pass over the surface. The terrain is dominated by dormant volcanoes that tower 3 miles into the atmosphere. Deep channels, forged 1 million years ago by molten lava, stretched thousands of miles, one longer even than the River Nile. Probe sensors reveal an atmospheric pressure 90 times greater than on Earth, large enough to crush a car. But the biggest problem is temperature. The atmosphere is nearly all carbon dioxide. Just like on Earth, this gas acts like a pane of glass in a greenhouse, letting the light through, but not the heat out. On Earth, increased carbon dioxide levels are causing small rises in temperature, But on Venus, they have pushed the temperature to over 900 degrees Fahrenheit.
Venus wouldn't be my first choice of a vacation spot in the solar system. You would be simultaneously burnt to death, crushed to death, and your body would instantly react in a very destructive way with a corrosive mix of toxic chemicals.
The environment is so savage that any spacecraft will have to be built from materials that can resist Venus's treacherous atmosphere.
Okay, here's some lead. This is a metallic substance that we normally think of as a solid on Earth, but let's see what happens when we heat it up to closer to Venus temperatures. You can see it's starting to melt right away. So that would not be a good thing to build your Venus spacecraft out of. That's why when we make our landing craft, of which we've made a few for Venus, we have to make them out of these very fancy titanium alloy kind of materials, the kind of materials they make fighter jets and things like that out of, that don't melt at these extremely high temperatures.
But surprisingly, although the surface is hot enough to melt lead, Venus may not be an entirely lifeless world. Billions of years ago, primeval Venusian oceans could have been home to simple organisms. Some scientists believe that when the temperature climbed, the waters boiled away. This would have killed many of the organisms. But some may have survived by migrating to the cooler clouds in the upper atmosphere. Grinspoon believes that if primitive life can survive the acid, then surely humans could.
I think people will go ballooning on Venus, because all you need, of course, to go into the clouds of Venus is a decent source of oxygen and some kind of a rubber suit so that your skin doesn't get burned off by the acid.
It may be possible to glide through Venus's upper atmosphere, but surviving on the surface is another matter. The high pressure and 900-degree temperatures would instantly crush and burn any settlers. Colonizing Venus is not an option. We must head further out, toward the last of the solar system's inner rocky worlds. This time, it's one that scientists think that we may just stand a chance of living on. But the challenges facing would-be settlers go beyond anything we've ever seen on Earth. Mercury and Venus can never support human life on any large scale. We pass Earth and move deeper into the solar system. The next planet is Mars. Could we one day settle here? Mars is the one world that most resembles our own. A Martian day is almost the same length as ours. Mars has mountains, deserts, and gaping canyons, cut in the distant past by running water. Traces of that water may still be locked beneath the surface, but to reach it, we would have to face an ancient danger: radiation. 5 billion years ago, when our sun was born, it blasted high-speed, energetic solar radiation out across the whole solar system. And it's still doing it today. Without some sort of protection, we could not possibly survive. We were lucky. Our world developed a magnetic field. This shield deflects deadly solar radiation away from the surface. But Mars has no magnetic field, and that means no protection. Over many millennia, the solar radiation ripped the atmosphere from the planet. Mars's water boiled, and most of it evaporated into space. The surface became a barren desert. For any future human visitors to the Red Planet, solar radiation will be a deadly hazard. Even with the protection of a spacesuit, the radiation can still penetrate. It tears through the body, bombarding and killing living cells, destroying DNA. If humans are to live and work on Mars's surface, we'll need some serious protection. So scientists are developing drugs. Astronauts would take these specially designed enzymes to mop up the radiation. Martian homes would need shielding too. Scientists have developed a special form of polyethylene plastic, lighter and stronger than metallic shielding, yet just as effective. The plan is to build it into the structure of Mars habitats, protecting the occupants. With this advanced technology, humans could one day consider populating Mars. But there's another hazard to overcome. After the radiation stripped the water from the surface, the planet was left covered with dry iron oxide dust. Meet the sandstorm, Martian style. These mini twisters are babies, dust devils just powerful enough to suck dust up into the atmosphere. The problem is, what happens next? Professor Ron Greeley has been studying atmospheric activity on Mars for over 30 years, knowledge vital for any human expedition to the Red Planet. Greeley uses a fan and frozen nitrogen vapor to recreate these twisters in the lab. They form when the sun heats the surface, causing a pocket of hot gas to suddenly rise, spinning through cooler air above. It sucks up fine iron oxide dust and punches it high into the Martian atmosphere.
The dust devils range in size from about a yard across to features that are as large as a football field in diameter. These can be quite large.
That dust has to go somewhere. Greeley believes the mini twisters could trigger much bigger storms.
We do, in fact, see local dust storms that grow to global proportions, clusters of individual dust storms that eventually merge. The entire planet is enveloped in dust, and we can't even see the surface through that dust.
But it's not just dust devils that can trigger trouble on a global scale. Wind blowing across the surface can kick up dust into the atmosphere, building into an overwhelming storm. This also happens on Earth. Satellites photographed a storm raging across the Sahara Desert in Africa, revealing its enormous size. The similarity with the storm on Mars is striking, and that much dust is going to cause problems.
When humans go to Mars, they have to be concerned about the infiltration of this very fine dust. It's sort of like baking flour, if you will, very, very fine grained.
The dust is so fine that even the slightest wind can blow it anywhere, clogging up machinery and air supplies.
Not only is the dust likely to get into every nook and cranny, but there are also properties of the dust that may pose a hazard. One of the considerations are the electrostatic charging effects. When little tiny grains bang together, electrical charges are built up.
Much like shuffling your feet on a carpet, the rubbing action between the grains of dust creates enormous static electricity. Up to 20,000 volts can spark between the dust particles. This could destroy electronics and life support systems.
When we think about the eventual human presence on Mars, we have to understand the dust regime, we have to understand the electrostatic effects, all related to wind-blown particles.
Perhaps one day we will conquer Mars's harsh environment, but this is not a world that would ever feel like home. We leave Mars and push on out toward the supersized worlds of the outer solar system, the gas giants. These offer new and even more extreme challenges in our quest for another home. First up is Jupiter. Jupiter is a mysterious world so vast that 1,300 Earth-sized planets could fit inside it. It's entirely made of gas. It has no solid surface at all. Its upper layers are a mass of swirling counter-rotating clouds. This is a planet racked with storms and high-speed winds. Professor Fran Bagenal has spent a lifetime studying the atmospheres and environments of Jupiter and its moons.
Jupiter is spinning extremely fast. It rotates every 10 hours. And so rotation is very important and drives those east-west winds that produce the belts and the zones, those stripes across the planet.
Jupiter's high-speed spin generates horizontal bands of clouds that wrap around the planet like a belt. When these cloud bands collide, they create massive storms. The biggest of these is the Great Red Spot, the largest storm in the solar system. As we approach, the scale becomes clear. It's 3 times the diameter of Earth. Near the spot's boundaries, turbulence spills around the edges. Winds here travel at more than 250 miles per hour.
It's true that it has a lot of similarities with hurricanes in that the outer edges, it's swirling around a lot faster. And so indeed the inner parts are more calm.
At first glance, the red spot looks similar to hurricanes. But there is a difference. Here on Earth, hurricanes feed off the warm waters of the ocean. But as soon as they hit land, they start to die. Our storms only last about 2 weeks. But Jupiter's different. The red spot has been raging for over 300 years.
The reason why we last such a long time is there isn't a surface on Jupiter. So it's not as if storms run into a continent and dump its energy. It just keeps going and going and going around and around.
But the spinning of Jupiter is not enough on its own to drive the Great Red Spot. Scientists discovered the planet gives out twice as much energy as it receives from the sun, suggesting its core must be hot. This center could be the powerhouse that drives Jupiter's winds. The core could be worth a closer look. As we descend through upper layers, vast water clouds envelop our craft. The pressure is climbing. Toward the center, it transforms the hydrogen atmosphere to a strange liquefied metal, resembling the element mercury. This is the core, a churning furnace at over 40,000 degrees Fahrenheit. Scientists estimate that the pressure here is 100 million times higher than on the surface of Earth.
How can I give you a sense of what that feels like as a pressure? Well, if anyone's had someone step on their toe with a stiletto heel, you know that's a lot of pressure. Now imagine an elephant wearing stiletto heels and standing on one foot on a stiletto heel. But to get the pressure at the center of Jupiter, you need to have about 1,000 elephants standing on top of each other, the bottom one on one foot on a stiletto heel.
At these sorts of pressures, humans could never journey to the core. But could we survive in the upper atmosphere? The answer to that lies on one of its moons, which has an extraordinary effect on the gas giant. It might be dwarfed by Jupiter, but this minuscule world packs a mighty punch. Our quest for a new home has brought us a long way. We are 365 million miles from Earth, in orbit around the giant planet Jupiter. Could we survive here? Perhaps in the turbulent upper atmosphere? That depends on what's happening around us. On Jupiter, that means looking at its moons. Io is tiny, but it's the most volcanic body in our solar system. And living next to a volcano is never a good idea. Dr. Rosalie Lopez is a volcanologist. She's come to the Kilauea volcano range in Hawaii, one of the closest matches on Earth to Io's fiery surface.
This is very much what the surface of Io may look like, particularly close to the lava flows. There would be lava flows just like this, solid at the surface with underneath us hot lava flowing.
Like Kilauea, Io spews lava from its superheated interior. But that's where the similarities stop.
The volume of lava that Io's volcanoes erupt is quite staggering. If we do a comparison with Kilauea, in 5 months, Kilauea might cover 4 square miles. But Io erupts about 100 times the volume of lava. One lava flow on Io covered 240 square miles.
Io's volcanoes are deadly, but they aren't the real killer. Before the lava can get you, the radiation will. Just 10 minutes on the surface, and you're toast. Even over 200,000 miles away, in Jupiter's upper atmosphere, an unprotected human could only survive a matter of hours. The volcanic particles that Io blasts out into space become trapped in Jupiter's enormous magnetic field. Jupiter's rapid rotation accelerates them to fantastic speeds. They're like microscopic cannonballs. They form a radiation belt around Jupiter, cutting through almost anything in their path.
They're sufficiently intense that a human would receive a lethal dosage within just 10 minutes. So you couldn't just fly through the system and survive, you would fry up. This intense bombardment would destroy your flesh and the organs inside, everything.
We just don't have the technology to protect ourselves from radiation this fierce. Jupiter is one planet we'll never call home. Could our next stop offer more hope? Saturn's radiation levels are lower, but it's not a danger-free zone. From Earth, Saturn appears almost featureless, but its appearance is misleading. Its rings may look solid, but in fact, they're mostly made up of billions of chunks of ice and rocks, ranging in size from pebbles to blocks as big as a car. All of them are moving faster than a high-speed bullet. But Saturn's real danger lies within its atmosphere. Like Jupiter, the planet has bands of high-speed counter-rotating winds. Clouds race around the planet at over 1,000 miles per hour. Along the edges where two bands meet, tiny particles collide, brushing past each other, generating an enormous electrical charge. Theory suggests that when the charge gets too great, the electricity arcs between the clouds, producing giant lightning bolts. NASA's Dr. Kevin Grazier is a planetary scientist who specializes in atmospheric conditions on Saturn.
We have a chance for a lot of charge transfer between one band and the other, creating large voltages, creating huge lightning bolts.
To get an idea of just how huge Saturn's bolts are, compare them with Earth. Lightning here can hit 50,000 degrees Fahrenheit in a split second. Striking the ground, it's hot enough to create a tube of solid glass, stretching down 15 feet. But compared to Saturn, that's a tiny spark. A single storm on this gas giant can cover the whole of America.
And you can also get storms that last for years. Storms on Earth last for a week or two. Storms on Saturn last for weeks, months, years.
With such an unstable atmosphere, even attempting to enter Saturn's clouds is deadly. As we push out and pass the featureless world of Uranus, we're heading for the very edge of our solar system. And out here, there are challenges that will test human visitors to their limits and beyond. In the future, humankind will journey to distant worlds, searching for new planets we could live on. Next stop, Neptune. At over 3 billion miles from Earth, observing this gas giant is a tough job, so astronomers go high, very high, way above Earth's clouds and pollution to get a clearer view. This is the Keck Observatory, 14,000 feet up on the summit of Mauna Kea in Hawaii. The telescopes here are so powerful, they could see a flickering candle on the surface of the moon. Dr. Heidi Hamill has been researching Neptune for over 20 years. Coming to Keck gives her the chance to study this distant world.
We'd see a beautiful blue planet, but that blue is not water like on our planet. That blue is the atmosphere of hydrogen, a little bit of helium, and most important, a smidge of methane.
Neptune may not have water, but it does have clouds. And these clouds allow Hamill to discover whether humans could survive this alien world. Standing out against the blue atmosphere, the clouds are easy to see. They form when methane freezes in Neptune's super-chilled upper atmosphere. The Keck telescope swings toward Neptune. Hamill takes a series of photographic shots, tracking the white clouds as they move around the upper atmosphere. Measuring the time and distance they move between 2 points, she can calculate just how fast the winds are blowing. The result comes as a shock.
Some of the winds that we've clocked on Neptune do seem to be some of the fastest in the solar system. Some of these little white puffy clouds that we've tracked are really fast. They blow almost as fast at some latitudes as 1,200 miles per hour.
In our quest for another home, one thing is clear: humans could never visit this alien world. Yet there is a near neighbor, a world without storms and with a solid surface. This is Triton, one of Neptune's 13 moons, super chilled and covered in frozen nitrogen snow. It would be big enough for us to live on. The question is, could we? Dr. John Spencer from the Southwest Research Institute in Colorado has been exploring the life-threatening hazards of Triton's icy climate.
The surface of Triton is probably quite bizarre close up. We have frozen carbon dioxide, frozen carbon monoxide, frozen methane on the surface, but also a great deal of frozen nitrogen. It might form snowdrifts and be crunchy underfoot.
Any human exploration of Triton's savage surface is life-threatening. At 390 degrees Fahrenheit below zero, we'll need some special space gear. With assistant Eddie Goldstein, Spencer uses liquid nitrogen to replicate Triton's environment. It allows him to see how materials will behave on this super cool world.
If you were to build a spacesuit that would function at Triton temperatures, you'd need something kind of flexible to make it out of. You might think you might use some kind of rubber material.
At room temperature, rubber is soft and pliable, ideal for creating airtight seals on astronaut life support systems. But drop the temperature to minus 350 degrees Fahrenheit, and it's a different story.
And just because something is flexible on Earth does not mean it is flexible on Triton.
The rubber molecules are flexible at warm temperatures, but drop them into chilled nitrogen, they become rigid as steel. The rubber hardens and shatters like glass.
I will drop it
The search is on for materials that remain flexible at super low temperatures. Scientists are looking at familiar substances, fabrics that you may be wearing at this very moment. Could nylon be used in the super chilled world of deep space?
And it's interesting because it's just as flexible even after it's cold. And it's not because nylon is anything special, it's because the nylon was woven into tiny threads.
The secret of the nylon's flexibility lies in the weave. The fibers remain pliable because each strand is as thin as a human hair.
So you might be able to make suits out of some material like this if you just treat it in a different way that takes into account this very unusual environment that we have out there.
Even if humans do manage to walk on the surface in high-tech spacesuits, there is one other danger lurking beneath Triton's surface.
All we see is these rather vague streaks, jets of material coming up from the surface.
These dark marks are the clues to Triton's hidden menace. Beneath the frozen surface lie oceans of liquid nitrogen. As the sun warms the moon, the nitrogen turns to gas. This pressurized gas explodes as a geyser, blasting moon dust high into the atmosphere. The black dust finally settles on the white surface, leaving dark streaks. Back in the lab, Spencer recreates the spectacle.
So what we're going to do is put the nitrogen in a situation where it's contained within this flask, just as it might be trapped underneath a layer of glaze ice on Triton itself, and the pressure would build up, and that would produce a jet that could maybe shoot up 6 or 10 miles.
Just like...
Hey, we've got a geyser.
Just as the pressure builds in the glass flask, on Triton, pressurized nitrogen, trapped under the surface, blasts moon dust into space. A world of violent geysers and crushing cold. With the right technology, humans could one day walk on the surface, but it's not a world we could easily colonize. Within our solar system, this is the end of the search. This far from the sun, any planet is cold and barren. After Neptune, there are only small, dead, icy worlds like Pluto. Beyond is the unknown. Out here, the possibilities are endless. And out here, perhaps we will one day find a place to call home. Today, astronomers are piecing together incredible new evidence in the search for distant worlds, planets that could support human life. Our sun is only one of 200 billion stars that make up our galaxy, the Milky Way. Any of these stars could have planets, just like our solar system. Tracking them down is the ultimate scientific quest, and king of the planet hunters is Dr. Jeff Marcy.
Our Milky Way galaxy is a glorious but enormous place. It contains 200 billion stars, and it's 100,000 light years across, and so we have to pick and choose which stars to observe.
This is the Lick Observatory in California, where planet hunters like Marcy come. He scans the night sky, searching for new worlds orbiting distant stars. But he has to pick carefully.
Luckily, there's this marvelous catalog called the Hipparcos catalog that has over 100,000 stars that are all very nearby. And what we've chosen, logically, are the nearest. In fact, the nearest 2,000 stars. They're all within about 200 or 300 light years of the Earth. Okay, Bernie, I think we can go to the next star. The next one will be Barnard's star. Do you have the
Every
coordinates?
star takes hours of painstaking observation.
1757.
Lick's 3-meter telescope locks on to its target. But even with all its magnification, a planet circling a distant star is too small and faint to be seen directly.
The real challenge in planet hunting is that planets, by their intrinsic nature, don't produce their own energy. They shine by reflected light, and if they're warm, they glow a little bit. But they are, in fact, about 1 billion times fainter than the host star around which they're orbiting.
So astronomers have perfected an ingenious technique to find these invisible worlds.
So we use a trick. And the trick is we watch the star, not the planet. As a planet orbits the planet pulls gravitationally on the star, making the star wobble to and fro.
To show how a planet pulls on a star, Marcy uses a simple demonstration.
Okay, so here we have a bag of rice, and it's going to simulate the planet, and I'm the star. And what happens, of course, is that the planet orbits the star, like so. And as the planet orbits the planet pulls back on the star and makes the star wobble. You might be able to see my body wobbling back and forth. And it's wobbling because, in fact, the sack of rice is pulling on me. And of course, the analog is quite perfect because the sack of rice acts as the planet, my body is the star, and this rope serves as gravity. And of course, all we see with our telescopes is the star. We can't detect the planet at all, so we just watch stars to see if they wobble to and fro. And if they do, they must have a planet.
To date, hunters like Marcy have found over 200 new planets orbiting distant stars. But can they determine what those worlds are like? Marcy believes so, by calculating how far the new world is from its star.
The longer it takes the planet to go around the star, the farther the planet must have been from the star. Close-in planets go around fast. Distant planets take a long time. The Earth, of course, taking 1 year.
He's discovered one world 1,100 times the mass of Earth that orbits 8 times closer to its parent star. Another planet is so close, it races around in just 3 days, making its surface thousands of times hotter than Earth.
Some of the planets we've found orbit so close to their stars that the temperatures are thousands of degrees. At those kinds of temperatures, ordinary metals like iron and nickel and titanium not only melt, they vaporize.
Instead of clouds of water, the atmospheres of these deadly worlds are filled with clouds of metallic vapor. But Marcy's convinced that not all alien worlds are so savage. He's decided to look at smaller stars that burn less intensely. Could their orbiting worlds be more like Earth?
What we hope to do in the next year is a glorious quest. We're going to observe low-mass stars and hunt for Earth-like planets. They're orbiting close, but next to a dim star, the temperature won't be too hot nor too cold, but just right for life.
Out here, countless worlds are waiting to be discovered. Perhaps some will have breathable atmospheres and oceans of water, allowing life to flourish. But finding them is a huge challenge. So far, scientists have drawn a blank. And judging by the deadly environments on the planets that make up our own solar system, it's not going to be an easy job. From the crushing heat of Venus to the erupting volcanoes of Io to the 1,400-mile-per-hour winds of Neptune. The worlds we have discovered are too savage for even our most advanced technology. The only planet that offers hope for human colonization is Mars. If we could overcome the dust and the solar radiation, one day we could live here. Maybe in the future, when Earth's climate is too extreme, Mars will become home. Until that day, humans will have to adapt, continuing to thrive in a constantly changing world.